So let's solve this. Problem number 4. So here what we have is two objects resting on a slope surface which is making an angle 30 degree with the horizontal. So we have block A and we have block B, and they are connected with a rigid rod. And when we say a rigid rod, it basically means that that rod won't be undergoing any change in length. So this is the rigid rod. This is A and this is B. And the information that is available with us is the weight of block A, which is 50 Newton, weight of block B 100 Newton, then mu A, that is the coefficient of friction between block A and the slope surface, is 0.15, and mu B is 0.3. And we are asked to we are supposed to calculate the force in the rigid rod. And here I am assuming that force to be compression. It's because when we have two objects, okay, consider I have two objects and it is connected using a rod is there. Now when this object is pushing the other one, you can see that the rod will be under, I'm using this hand and I'm pushing it. Now we can see that this rod is under compression. When I'm pulling it, okay, this rod will be under tension. So when we are using a pulley arrangement and a cable arrangement, what happens is that there is a pulley and the cable, okay, and because of the pulley, on the two sides of pulley, the objects will be moving apart, so they will be pulling it, so the cable will be under tension. Here it is opposite case, one object is pushing the other object using the rod, so the rod will be under compression. So I'm assuming the value to be C. So let's solve this one. Okay, so here also we are going to use the perfect tool, which is free body diagram. So I'm starting with say free body diagram of A. Anything is fine. So I have a block on a slope surface. The weight is acting downward and it is given as 50 Newton, and it is making an angle okay. So it is said that this angle is 30 degree, which means this angle will be 60 degree. Now reaction will be there. Reaction will be normal to the surfaces in contact. Here the surfaces in contact is the slope surface and block A, so I'm calling it as NA. And the rigid rod is there. The rigid rod is applying a force which is compressive in nature. I'm calling it as C. Earlier, all cases we were marking it away from the object because we were marking tension, all the previous problems. But here we are marking the arrow towards the object because we are considering compression. Compression means it is compressing. So if I consider this body, this is pushing it. Or if I consider this body, this rod is pushing it. So it is compression. And now we need to mark the friction. So this block A is trying to slide down. So the friction will be opposing the motion. So the direction of friction is this, and it will be mu A times NA. And the next component we need to mark is the direction of acceleration. As this block is sliding down, the direction of acceleration is this. It is sliding down, and here we can see that the acceleration for block A and acceleration for block B will be in same magnitude and in same direction because they are moving together. So everything is having acceleration in this direction with the magnitude A. Now let's define some coordinate system. Okay, I'm defining the coordinate system like this. Let this be my x, this be my y, positive x and positive y. So I'm writing sigma fx equal to max, right? So I need to consider the direction of the magnitude of acceleration in the x direction. This is my x direction. If we observe the block is having zero acceleration in this direction because the block is not moving in this direction, it is only moving in this direction. So ax is 0. So this term becomes 0. Now I can write the different values. So in the x direction I have in A, that upward direction, positive direction, then 50 cos 60 is this, so 50 sin 60 in the opposite direction. So 50 sin 60. Then is there any other forces? Nothing is there. Equal to 0, which implies NA is equal to 50 sin 60, which is 43.3 Newton. We got one value. Now let's consider the equation in the other direction. Sigma Fy is equal to MAY. Now this is the y direction. Okay. So what about the acceleration AY? I have marked A like this. My y I assumed in the upward direction. So this is opposing. So AY is minus A. Okay. According to the coordinate system I chose, A is negative A. Okay. AY is minus A because this is the positive I considered. A is in the opposite direction. Now let's write the Fy condition. So I have mu A N A in the positive direction, then 50 cos 60 in the negative direction, 50 cos 60 negative direction. Then I have C in the positive y direction. Okay, so that's the left hand side, that is the forces mu Na, 50 cos 60 and C. This is equal to m times minus A. For block A the weight is 50, so mass will be 50 by 9.81 into minus A. So that's my equation 1. So let's substitute the values. Mu A is available, it is 0.15. 0.15 times Na, 43.3 minus 5 cos 60 plus C is equal to minus 50 by 9.81 A. That's my equation 1. So I have two unknowns, A and C. So if I have two equations, I can solve those. So let's try framing the second equation. So to get the second equation, I can plot the free body diagram of B. So I'm plotting the free body diagram of B. So this is the block B. The weight of the block is acting downward. The weight of the block is 100 Newton. So 100. And it is making an angle just as before. We have seen this. This is 60 degree. Okay. As this angle is 30 degree. Then this block B is in contact with this surface, so there will be a normal reaction in B as it is block B, and then this rigid rod will be applying a compressive force which will be in same magnitude as C. As it is compressive force, I am applying it towards the object. If it was tension, I would have it drawing it away from the object. Then I need to see the frictional force. This block is sliding down, so frictional force is upward, that is mu b nb. And then I need to think about the acceleration. This object is moving down, so acceleration is in this direction. Okay, I have considered a here, so here also a, because everything is moving together, so acceleration will be same for all the objects. Now again I'm going to write the same set of equation. Here also I'm going to use the same coordinate system. So first I am trying to write sigma fx equal to max. So just as we have seen earlier, the value of ax is 0 because acceleration in the chosen x direction is 0. So I will be getting nb, then minus 100 sine 60 equal to 0, which implies nb is equal to, I have the value as 86.6 Newton. Now we are going to write sigma fy equal to 0, not 0, sorry, m times ay. And as we have seen before, ay is going to be minus a, because y, I assume this as positive, a is in the opposite direction, so it is minus a. Now I'm writing sigma fy, so I will be having mu b nb positive, then c negative, 100 cos 60 negative. Okay, anything else? No. Now the right hand side, that is mass times minus a. Mass is 100 by 9.81, that is 100 is in Newton, so mass, weight is 100, so mass is 100 by 9.81 times minus a. So here also I can substitute the values. So mu b is 0.3, 0.3 into 86.6 minus c minus 100 cos 60 is equal to minus 100 by 9.81 times a, and that forms the equation 2. So here we made a small mistake. It is not 5, it should be 50. Now we have two equations, equation 1 and equation 2. There are two unknowns, the acceleration and the value c, which is the compressive force in the rigid rod. On solving these two equations, these are simultaneous equations, so you can use calculator to solve this. The value of the final result, what you will be getting is that you will be getting the value of a as 2.78 meter per second square and the compressive force c as 4.33 Newton. Okay, these are the expected results out of this particular problem. The compressive force in the rigid rod, we got it as 4.33 Newton.